Hello, my name is Dylan. My YouTube channel is Derek G Bros, and welcome to another video. And so today what we're going to be doing is a Gaussian elimination. So this is a new way to solve linear systems. Okay? So let's take a linear system. So let's just write a random one. Let's do a 3 by 3. And we'll do 2x plus 4y plus 6z equals 26. Four x plus 10y plus 20z equals 68. Lastly, 2x plus 7y plus 20z equals 52. Okay. So, I'm just going to quickly show you what our goal is in a Gaussian elimination. So, I'm going to get a new piece of paper. If you don't, that's okay. So, I'm going to show you a little bit ahead into what we're going to do. So, we're going to turn our old problem into this. Okay. Notice I'm using like brackets instead of like linear system brackets. And it's going to be 1, 2, 3, 13. 0, 4, 0, this is a 1, then it's a 4, and then it's an 8. Then lastly, it's 0, 0, 1, 1. Okay? And so basically our goal is to make what's called a upper triangular form, which is that. And if I explain why we want how this is gonna so basically this is near the end of the problem. This will give us our answer. And we're going to do backward substitution. Okay? So this is called the upper triangular form. There is a lower, but I'm not going to talk about that right now. And so, what we need to do is we're going to get to here. If you work everything out correctly for this problem, you're going to end up with that. So back to our original problem. It's going to be so what we do is step number 1 to solve it is to change it to matrix notation. So we changed the brackets. We added double blocks. So we had 2 matrix blocks. And then basically what it does is we remove all symbols. So X, Y, Z equals and plus. So what it will end up looking like is a matrix. So 2, 4, 6, 26. You see what I mean? And then it's 4, 10, 20, 68. 2, 7, 20, 52. Okay? So, actually what we're going to do is we're going to write a little bit of, we're going to basically kind of like a program that will help us kind of narrow it down so we can get our upper triangular form. So how we're going to do this is basically we're going to make a fraction, and so half of this number so basically what we're trying to do is get a 1 here, and all of these don't matter. So this number is 2. So what we're going to do is we're going to flip this number, which is called a, so this number actually has no special name, it's what we do with it. So the reciprocant of this number, which is the main number we're focusing on, to try and make that a 1. The reciprocant is the number that when you multiply it by this number or subtract it from that number, it will always give you 1. So in this case, that reciprocant, well, actually it's divide, so it's 1/2. What is that? It's 1/2. So 1/2 of 2 is 1. And now this is a little confusing. R1. And you might be wondering, what the heck does this mean? So basically, 1/2 of 2 is 1. And basically, this is like a little line of code. So R1 is row 1. So 1/2 of 2 is 1. I'll show you. You might be. So it's here we have 2. Now if we put this programming into use, so it's 1/2 2. So half of 2 is 1. Now it says R1 to R1 arrow R1. So basically it's it's row 1 being put into row 1. So we do all this, so like that, and then like that, and all in row 1, and then we put it in row 1. So if you want to know the answer, it's 1, 2, 3, 13. Okay? Now, since there's no little lines of code or whatever you want to call it, you just put the numbers as they are. So it's 4, 10, 20, 68, 2, 7, 20, 52. So now what we can do is, for this problem, we can write another line of code. And this one is for the second row. So what we're going to try and do is make this a 0. And so how you get numbers to be a 1 is using the reciprocant. But here what you'd use is you add 2 rows together. You don't know what I mean? So let's write our little line of code. So that's 4, so it's going to be -4. Row 1. So we're adding row 1 to row 2. And we're going to place this in row 2. So basically what that is, so negative 4 times 4 is negative 16. Oh wait, I did something wrong. Negative, so it's basically goes like, how it goes is, it's negative 4 to row 1. So it's basically negative 4 plus 4, because that multiplied by that is negative 4. And then negative 4 plus 4 is 0. So it's going to be 1, since there's no line of code here, we do 1, 2, 3, 13. Now here we're going to add new code. Like we're going to add new numbers, because there is code there. So the next one, if you want to work it out, now's the time to do it, is 2. Third one is 8. And the fourth one is 16. And then the bottom row stays the same. But not for long, because this next step, 52, this next step is going to change the bottom row. Because what we're doing now is we're going to try and turn this into a 0. So it's going to be negative 2, round 1, plus round 3, and we're placing it, row 1 plus row 3 equals row 3. So we're going to draw a bracket. And what we're going to do is we're going to figure out what these are. So this row, the top row stays the same. 3, 13, and so does the middle. The bottom does not. That's why that's how this code comes in. So, if you guys want to know the answers, here they are. It's 0, 3, 14, 26. Okay? And now what we do is, because we don't have, now that what you need to do is put a 1 here, we need to do another reciprocand. Now this one's easy, due to the fact that it's the same number as the first one. So it's going to be 1/2. It's going to be 1/2 R2, or row 2, and we're going to place it in row 2. So half of row 2 is going to be, so let's just write the first 1, 2, 3, 13. And now 0 is the same. 1, 4, 8. Okay. And the bottom row stays the same. Okay. So now what we're going to do, we're going to, we're we're going to do the code, which is in the bottom row because we're trying to get a 0. -3, row 2, or R2, plus R3, place is in R3. So if I'm going to solve that right now. So top and middle stay the same. 2, 3, 13, 0, 1, 4, 8. Now the bottom is not going to be 0, 0, 2, 2. Okay, now what we're going to try and do is we're trying to make this 2 right here a 1. And how we do that is a little complicated. Just stick with me. Actually, no, it's not. It's pretty simple. But just stick with me. So what we're going to do is we're going to do our reciprocant. So it's 1 1/2 again, because it's still a 2. R3. And it's going to be placed on R3. So it's gonna now be that we have, trying to put in the reciprocant, it's gonna be 1, 2, 3, 13, 0, 1, 4, 8, 0, 0, 1, 1. Okay. Actually, at this stage, we have our little triangle. And now you want to know why we need the triangle? I'm going to have to get a new page. And it's because we're going to have to do... Now we're going to change it back to what it was. You know, if you don't know what I mean by that, now that we have a triangle, we're going to add all the extra, like, letters. So it's going to be X. Actually, I did this wrong. It's supposed to be one of those kind of swirly brackets. But it's going to be X plus 2y plus 3z equals 13. Now, since there's a bunch of zeros here, here, and here, we just leave them blank. So it's going to be y plus 4z equals 8. Then it's going to be 1z equals 1. So now we know what z is. Z is 1. So now we're going to draw our little teeny bracket. Now we're going to do the second line. This is why it's reverse substitution, because we start with z and we go to x. Normally we do x and go to z. So it's going to be y plus 4, which is times 1, equals 8. Which means that y equals 4. And now we can do x. So it's going to be x or x. You said when equals, that's supposed to be a plus 2 instead of y, it's 4. Plus 3 instead of z is 1 equals 13. Which, I'm going to do that little math, so it's going to be x plus a plus 3 equals 13. And then it's going to be x plus 11 is 13, which means that x is equal to 2. So now we figured out limits 1, 2, 4, or actually more properly it's 2, 4, 1. That's our final answer, so it's going to be 2, 4, 1. Since it's our final answer, we're going to box it. But we're not done. We think that's our final answer. We could have made a mistake on the way. So even if you are like pretty much positive you didn't get something wrong on like a test or something, you're absolutely positive, you should always refer back to your work. So let's go to the very start of the problem. So let's rewrite that. Rewrite the first problem. 2x plus 4y plus 6z equals 26. 4x plus 10y plus 20z equals 68. I'm just going to say something right now. The Gaussian elimination is the professional way to solve linear systems. It might not be the easiest, it might not be the fastest, it might be the fastest, it might be the easiest, but this is the most professional way to do it. And then for the last row is 2x plus 7y plus 20z equals 52. So now what we're going to do is we're going to rewrite the problem again, but instead of writing the x's, y's, and z's, we're going to replace it with what it was, 2, 4, and 1. So instead of going to be 2x, it's going to be 2 plus 4 plus 6 or 6. I'm just going to say that's a 1. I'm just going to put 6 there. 6, 1 equals 26. 4, 2 plus 10, 4 plus 21 equals 68. And 2 plus 7, 4 plus 21 equals 52. Now we're going to multiply them together. So it's going to be 4 plus 16 plus 6 equals 26. 8 plus 40 plus 20 equals 68. And 4 plus 28 plus 20 equals 52. And we're going to make it even smaller. Just going to narrow it down to 20 plus 6 equals 26. And then 48 plus 20 equals 68. 32 plus 20 equals 52. So now, even though this is unprofessional, I'm going to write it to the side. Now, if you want to do it really professional, you'd get a new page, even though you're just going to write down a little equation. So now, this is our final step of checking our work. I'm just going to make a line right here and say, check. So this is, actually the line should be here. But this is where the problem ends, up here. And then our checking starts here. So it's going to be 26 is equal to 26. That is true. 68 is equal to 68. That is true. And 52 is equal to 52. And that is true. So now we know that our problem is correct. Thank you guys for watching. I hope you enjoyed this video, and I'll see you next time.